Hello everybody. Today we are going to be working on page 120 in our workbooks on lesson 614. Make sure you get your calculator and also a pencil. You will need both of those today. All right, we are going to be starting with 14.1. So the height in inches of a frog's jump is modeled by the equation h of t equals 60t minus 75t squared, where the time t after it jump is measured in seconds, okay? And we have height in inches as well. So I want you guys to use that equation, and we are going to find h of 0 and h of 0.8, so you can plug both of those into your equation here. Plug those in for t. And then we also want to interpret what do those values mean. Okay, so give it some context. Go ahead and start with that one. And then our second question, how much time after it jumped did the frog reach the maximum height? Okay, so since we're looking for maximum height here, this would be our vertex. So take a few minutes, go ahead and pause the video, talk with your group, figure out the answers to these for first two questions here, and then you can continue playing to check your answers. All right, so we should have gotten, if we plug in 0, we get 60 times 0, which is 0, minus 75 times 0 squared, which is also 0. And then if we plug in 0.8, we would also get 0 for that because 60 times 0.8 is 48, and then 75 times 0.8 squared is 48, which gives us 0. So, very important, those 2 points, because our y values are 0, those are our x-intercepts. So, if you guys remember from Friday, the vertex is in the middle of those two x values. So if we have 0 as the x value of our first x-intercept, and then 0.8 as the x value for our next one, the value in the middle, that is the x value of our vertex. So I know that 0.4 seconds is our x value, and we can just go ahead and plug that in to find that output value of 12. So our max height was 12 inches after 0.4 seconds. Okay, as you're going through today's lesson, if you have any questions, please write them down in your workbook, circle things that you're confused about, and we can go over those together. So we are going to be talking about graphs that represent situations today, okay, expanding on that idea a little bit more. Okay, so we're going to be looking specifically at paths of objects that are being launched in the air, okay? And we've been talking about that a little bit already, so we're just going to explore that a little bit more. Okay, zoom out a little bit here. So here we have the equation h equals 2 plus 23.7t minus 4.9t squared represents the height of a pumpkin that is catapulted up in the air as a function of time, t in seconds. The height is measured in meters above the ground. The pumpkin is shot up at a vertical velocity of 23.7 meters per second, okay? And remember, we have those 3 parts, so that 23.7 is represented here. So again, I want you guys to go through these 4 parts on your own, and then answer these questions, then play the video and check your work, okay? So go ahead, pause the video, complete those 4 parts, and then continue playing to check your work. Alrighty, so our first answer, the positive 2, that is our initial height or starting height. Okay, so we've talked about these back in our first half of this unit. And then the negative 4.9t squared is the coefficient due to gravity. Negative 16 is when we're measured in feet. Here we are measured in meters, which means that this is our coefficient for gravity. Okay, still the same idea though, because it is with our term that is squared. Second question, our graph would be opening down because the coefficient of x squared is negative. So yesterday we played around with some different values, and every time we had a negative in front of that x squared or t squared in this problem, our graph would open down. Vertical intercept is just another way of saying y-intercept, which again is our starting height, which is 0, 2. And our horizontal intercepts, one of them would be negative because we're starting at 0, 2. Okay, so if we had a graph right? And I'm starting up at 0, 2. My graph looks something like that. The one x-intercept would be down here, which is negative. So we don't necessarily care about that one, but we do care about this one. So there's two ways you can figure out what that would be. You can either plug in different values of t into your equation and make a table, or you can graph your equation. So if we were to graph this, let's see. So we have 2 plus 0.7. There we go. Oh, I clicked out of it. There we go. 0.7 x minus 4.9 x squared. Okay, we can zoom around on our graph here and find that intercept. So we can see that that point is just before 5. It's at 4.92. But we don't have to be exact here. We just want to get an estimation about where that value would be. Okay, so I just said that horizontal intercept would be around 5, 0. Okay, you could do that on Desmos or on your graphing calculators as long as you're close. Okay, we just need an estimation. Again, write down any questions you have or anything that is confusing today. Okay, so our next question here, we're dealing with the same situation. Okay, so this is all the same, but our next question is we want to graph the equation using graphing technology. Okay, so we are going to do that on our calculator, and then we want to identify the vertical and horizontal intercepts and the graph of the vertex. So here we actually already found the vertical. That was our 0, 2. And then we will have to find that negative one, the negative x-intercept, but we are at about 5. Oops, I wrote that backwards. Sorry about that. Okay. So we do know that we're at about 5, 0, but we do need to find the negative one, so we can check that on our calculators. And then we do need to find the vertex as well. Okay, so once we find this value, we will be able to do that. All right, so like I said, we're going to be using our graphing calculators today. So we can go ahead into our y equals, make sure everything is cleared out that you don't need. There we go. And we're going to enter our functions. So we have 2 plus 23.7x. It doesn't matter if we use x or t, so just go ahead and use that x button there. Minus 4.9x squared. Okay, we're going to go ahead and hit graph and see what we have. Okay, so far, not a bad picture. I can see both x-intercepts. I just can't see that vertex there. So I'm going to shrink down my x-axis a little bit so I don't have quite as many negatives. And then I'm going to make the y-axis a little bit larger. So we can do that in our window. Let's say instead of -10, I'm just going to go to -3. And then let's try 20. You can play around with different values too and see what that gives you. Okay, so better picture. I just need to go a little bit higher on the y. Okay, so let's try 30. Almost. 40. All right, cool. There we go. So go ahead and adjust your window. Once you have something where you can see your entire graph, then we are good with that. Go ahead and hit your trace key. That's going to move your cursor. See how mine's moving along my curve here? So we can go ahead and move my cursor until we get to about the top there. So we can see that my maximum is at about 2.44 seconds and 30.6 is our max height. Okay, and then the other point we want to check is that first x-intercept. So I'm pretty close there. That's at about -0.04. So that's pretty close to 0. So we can use that as well at about let me move that a little bit. Okay, so we might be a little bit closer to about -0.8. Okay, so we'll go ahead and use those 2 points. Alrighty, so we can go ahead and interpret these points. Our 0, 2, that is our initial height. of the pumpkin. Okay, then we had our negative 0.8, which was our 0 there. That is one of our zeros, but there's no meaning in this context because remember our x values or t is measured in seconds. So we can't really make any meaning of this because we can't have negative time. So there's really nothing that's happening there. But this next one is another 0, and this is when the pumpkin hits the ground. And then our last point that we need is our vertex, which we saw on our calculator, was at about 2.4 and 30.7. So this would be at 2.4 seconds. The pumpkin reaches a maximum height of 30.7, and we are talking in meters. So this would be meters, okay? That vertical intercept would also be in meters. Okay, so we've interpreted all of those points. Make sure you pay attention to this part on different quizzes, tests, homework assignments, that you're not only identifying, but we are explaining what they mean as well. All right, and now we're talking about the flight of two baseballs. So we have a graph that represents the height of a baseball, h in feet, as a function of time t in seconds after it was hit by player A. The function g, which is defined here, also represents the height in feet of a baseball t seconds after it was hit by player B. Okay? Without graphing function g, answer the following questions. Okay, so that's our keyword here, is without graphing, or key phrase. Okay, and then explain or show how you know. So which player's baseball stayed in flight longer? Because this is given to us in factored form, we can figure out what those intercepts would be. Okay, so this first one, we're looking for a value that would make that be 0. So that value of t for that first one, that's going to be our negative because we have this negative sign out front. So that's going to be like if I were to extend this graph, that would be my negative x-intercept there. So the intercept we're worried about is this one, t equals 4. Or sorry, t minus 4. That's going to give us, where our ball hit the ground. So if we have t minus 4, that's going to give me an x-intercept of 4, 0. Okay? If we look at our graph for player A, this has an x-intercept just after 5. So think about which ball stayed in the air longer. That's going to be player A, because their ball hit the ground after 5 seconds. And player B's ball hit the ground after 4 seconds. Okay, so that one stayed in the air longer. Which one hit a maximum height? Okay, so we are able to see, I would personally just, well, it said without graphing. Okay, never mind. So we can go ahead and find that other 0. Okay, so the way that we do that is we need to figure out what makes this have a value of 0. So if I have, I'm going to do this off to the side here, negative 16t minus 1, I want to know when would that equal 0. So we need to solve that for t. So I'm going to add 1 to both sides. So I'm at negative 16t equals 1, and we can just divide both sides by negative 16, okay? So if we have that as a decimal, that's going to be negative 0.6, okay? So these are the two zeros of this function. So we can figure out what the middle would be. That means we need to take the average. So I'm going to take negative 0.6 plus 4 and divide by 2. So negative 0.6 plus 4 gives me 3.4. If I divide that by 2, that gives me 1.7. This is the x value of the vertex, okay? We can plug this in to our equation here for t to figure out what the output would be. So we have parenthesis negative 16 times 1.7 minus 1, and then t, oops, not t, we're plugging in 1.7. 1.7 minus 4, okay? So negative 16 times 1.7, that gives us negative 27.2 minus 1, and 1.7 minus 4 gives us negative 2.3. Go ahead and type this in your calculator exactly the way that it's written with parentheses and everything. And then you should get 64.86 feet. Okay, so that is player B, player B. And then player A, we can see this is about at 5, that's close to 0. This is roughly where the vertex would be, which we can see that's the highest point. Okay, and we don't even need an exact value to compare these two, right? Because we can see that this point is well over 100, and this only got to 64. So player A is definitely higher than player B, okay? Now, something I want to point out with this question, remember it said explain or show. So doing this work is showing how we figured out these values. So we don't necessarily have to write an explanation here because we showed the math behind how we got this answer. Okay, and then how can you find the height at which each baseball was hit? All we need to do here for both of these was find the vertex and compare the y values, okay? Because that's what we did. We compared the y value of 64 and the y value of 100. Okay, we are going to skip the info gap for today. So go ahead and do the homework. We are not skipping any problems. You are going to do the entire assignment. I've already edited some problems out for you. So go ahead and do the entire worksheet. And then there is also a closer for today that is on paper. Okay, so you do have a paper cool down. That does need to be done today in class and turned in before you leave. Okay, make sure you write down any questions. We can go over any of those next time I see you guys.